For this example, we would like to differentiate the function f of x is equal to tan x. So to begin, we should recall that tan x is equal to sin x divided by cos x. So we have a quotient. Now to differentiate a quotient, we need to use the quotient rule, and the quotient rule tells us that when we differentiate u over v, we get v u prime. Remember, u prime means du by dx, minus u v prime is dv by dx, all divided by v squared. So the first thing we need to do is define our u and our v. Now u is always the numerator in the quotient, so in this case it is sin x, and v is always the denominator in our quotient, so in this case it is cos x. So to find the derivative we need u prime, so that means differentiate sin x, and when we differentiate sin x we get cos x. And we're also required to find v prime, so v prime tells us differentiate cos x, and when we do that we get minus sin x. Therefore, the derivative of tan x is equal to v times u prime, so that is cos x times cos x, minus u, which is sin x, times v prime, so that is a minus sin x, and that is all being divided by v squared, which is cos x, all squared. So we can tidy up the numerator here in our quotient. We can see we get cos x times cos x is cos squared x, and then we have minus sin x times minus sin x, so that will give us a plus sin squared x, and that's all divided by cos squared x. Now thinking back to our section on trigonometry, cos squared x plus sin squared x is equal to 1. Therefore, the derivative of tan x is equal to 1 over cos squared x. And we should also remember that 1 over cos x is sec x, so we can say this is sec squared x. Therefore, the derivative of tan x, which we have found using the quotient rule, is equal to sec squared x.